All right. In this problem, you have three bags, A, B, and then C. The bag A has 2 silver, bag B has 1 silver, 1 gold. No, this one has 2 gold. And this last one has 1 silver, 1 gold. And let's say you were blindfolded and you randomly picked a bag and you drew out a coin. And the question is, what's the probability that the other one, let's say you drew out the gold coin, okay? Then the question is, what's the probability that the other one is gold? Well, your intuition might say, since the gold coins are from here or there, right? So the probability should be like either this one or that one, so 1/2, right? So that's your gut instinct. But it turns out that it's bigger than 1/2 because of the following reasoning. If you chose C, you only have like 1/2 chance of getting the gold coin. But if you chose B, you have 100% chance of getting the gold coin, right? So it's more likely that if you know that in your hands is the gold coin, it's more likely that you're holding the bag B. You got it from bag B, right? So by that reasoning, you can argue that the actual probability should be more than 1/2. Okay? Does that make sense? All right. So in order to make this work, you need to use proper notation. It's really helpful. So let's say we want to know, so what are we trying to calculate? We want to know if it's bag B, because bag B is the case when the other one is gold, right? So we want to know probability of bag B if you know that what you have right now is a gold coin. Okay? And this is a conditional probability. Okay? And this is a very classic example of the Bayesian theorem, because Bayesian theorem allows you to switch these two around, right? And the formula for the Bayesian theorem is switch these two around, which is P of G under B, and then you multiply this probability while dividing it by this other one. Okay, that's the formula for Bayesian theorem. And if you ever get confused why that's so, then just remember that P of A under B, by definition, is the probability of A intersect B over probability of B. So what does this mean? This top part means, this right here means, this is P of G intersect B over P of B, right, according to this definition, right? And you're multiplying out the P of B so that they cancel. So this top part is really same as just this. But if you divide this by this, it is indeed PB under G because of this same formula. Okay, so it's always good to check what you wrote down by using this definition just to make sure that what you're doing is correct. Now, once you do this, then you realize that PG of B is much easier to calculate than PB of G. This is not, we're not so sure what this is, that's why we're trying to calculate. But what's the probability of getting a gold coin if you pick bag B? 2 out of 2. There are 2 gold coins out of 2 coins you can pick. So this one is 2 out of 2, which is just 1. 2 out of 2, which is just 1. And what's the probability that you're going to choose bag B? There are 3 bags, it's equally likely, so it'll be 1/3, right? And usually when you apply the Bayesian theorem, the denominator is what's challenging. P of G is always the challenge. And P of G in many cases are obtained by using the summation rule. So we'll just leave it like this for now, but let's think about this. The probability of getting a gold is sum of three probabilities. So there are three cases, right? So what if you chose bag A, and then you multiply by getting a gold if you choose bag A. So that there could be this case. Of course, this is 0, so this will just come out to be 0. But it could also have been that you chose bag B, and then you have to, in that case you have to calculate what's the probability of getting a gold if you chose bag B, and then plus if you chose bag C, you have to multiply the probability of getting gold if you chose bag C. Now, all of these are equally likely, so these are 1/3 each, but probability of getting gold from bag A is 0 because there's no gold coins here. Here, the probability of getting the gold is 100%, it's 1, and this is 1/2 because half the coins in here is gold. So you end up saying it's 1/3 times 0 plus 1/3 times 1 plus 1/3 times G under C is 1/2. Okay. Now, if you do this calculation, you end up with just 1/2. So you have to do fraction calculations. So once you get that, now we can plug that value in here and get, this is 1, so 1 times 1/3 is just 1/3 on top, divided by 1/2. And dividing by a fraction is multiplying by its reciprocal. So it's same as 1/3 times 2 over 1. And when you multiply a fraction top to top, bottom to bottom, you get 2 over 3 as these. Okay? So indeed, contrary to your gut instinct that, oh, it should be like either this or that, so it's 50/50. No, there's a lot more probability that the other one is gold as well. It's counterintuitive.